Okay, hi guys. So in this lecture we'll be seeing Benzyne mechanism. Okay, so let me write down first the heading part. Let's see one example of it. Suppose we have a chlorobenzene and we are reacting it in presence of KOH and we are providing 300 degrees Celsius. So let's say we have C star here, and what does the star implies here? C star is nothing but isotope of carbon. Okay, so what we see that we get something like this as the products, a mixture of this and this. Okay, this is called DSP and this is called LSP. DSP implies direct substituted product, and LSP implies line substituted product. Okay, so we will see what actually the mechanism internally works and how does we have DSP and LSP formed as a result. So please remember that this structure is called benzyne. A triple bond between this any two carbon atoms in a benzene is called benzyne. Okay, let's look at another example. We have chlorobenzene, and obviously this is H attached to the chloro group. So and we react it with NaNH2 and we are heating this. So what do we get is we get something like this, which is called aniline. Okay, so please remember that for the benzyne mechanism to happen or to take place, we must have alpha hydrogen, okay, to the adjacent to the carbon having the leaving group. Okay, what actually happens when we have something like this OCS3 and CH3 at adjacent carbons, and we are again heating it in presence of NH2, so no reaction happens. Okay, so alpha hydrogen is a must for benzyne mechanism. Okay, let us take some more examples. I hope that I in the previous lectures have mentioned about KMnO4 regarding its oxidizing nature. So KMnO4 is a very good oxidizing agent. Okay, and the reaction of KMnO4 also requires the compound to have alpha hydrogen. So now we'll be seeing reaction with KMnO4 of certain organic compounds where alpha hydrogen is a must. Otherwise KMnO4 won't show any reaction. Okay, so just remember that whatever the compound is, as this phenyl ring is having a 3 alpha hydrogen, what it will do on reaction with KMnO4, okay, it will just oxidize this CH3 group, and the maximum oxidation can be done for a simple carbon compound will convert it into carboxylic acid. Okay, similarly if we have something like this, we have CH, let's say we have something like this C14H3, this is a carbon and this is a carbon atom. So what will happen is the alpha carbon attached to this benzene ring is obviously this one. Okay, and this actually has alpha hydrogen. So what it will do is it will first oxidize this carbon, and then what it will do, it will also oxidize C14H3, so we'll get C14O2. okay, this compound, this is the alpha carbon and this also contains alpha hydrogen, hence what would be the final product? We'll have CO2H. Carboxylic acid is directly formed. Okay, what about this substrate when reacted with KMnO4, what will happen? Obviously we will need some heating, so we'll get something known as phthalic acid, CO2H on adjacent carbon atoms in a phenyl ring. We'll get phthalic acid. Okay, what happens if we have something like this reacted with KMnO4, and we also provide basic medium afterwards? Okay, what will happen is we'll get something like CO2H on again adjacent carbons, and this group would also be oxidized. I am not just showing here, okay, I'm just showing the major product, not the side products. Now what will happen if we have a benzene ring and something like this structure react with KMnO4, slightly heat this compound? No reaction takes place as there is no alpha hydrogen in this compound. Okay, what happens if we react? We have CH3 on the para positions and we react it with KMnO4, slight bit of heating may be required. We get tetraphthalic acid, CO2H on para positions. This is called tetraphthalic acid. Okay, now the last example is we have something like a aldehyde. Obviously this is the partial oxidized form of carboxylic acid. Again we oxidize it. What will happen is there is a position wherein O can enter between C and H bond and can form something like CO and H. Okay, so it will fully oxidize it. This is a good oxidizing agent. Okay, so what it will do is we will have again a benzene carboxylic acid. So with this we come to an end of this lecture. In the next lecture we'll be seeing some more examples and we'll see the mechanism of benzene. Okay, so till then, good luck and goodbye.